lesson, we learned that evolutionists claim and some believe that humans have evolved from an ape-like ancestor. Now, we're going to look in this video at the evidence for this claim, specifically what do living modern humans have in common, why are we closely related, why we're related to apes, and then if we're going to specifically look at that, also going to look at fossils and how fossil evidence provides justification for this theory. Now, we've already looked at what apes and man have in common. And we use the acronym APE equals man to remember the 6 criteria used to look at the similarities that we have. Now, although there are similarities which kind of indicate, okay, we're closely related, there are differences that make us distinctly human. The following characteristics are what paleontologists will look at when they find a fossil to determine, although it is ape-like, that it is not human. And it includes the following. It's bipedalism, brain size, teeth, the shape, palate shape, prognathism, which is the shape of the lower jaw, and then cranial and brow ridges. Now, I know these are it's just a mouthful, so let's make it shorter. To distinguish these characteristics in Homo sapiens, we will learn the acronym BLOB. Yes, indeed, BLOB. So the first B stands for bipedalism, the ability to walk upright on 2 legs. The L is for large and highly developed brain with a rounded skull and a distinct forehead and smaller jaw. And then the O would be for an omnivorous diet, which is evident from the rounded dental arch and smaller canines and molars. And then obviously body hair, which is reduced, hence the blob. Now let's look at each of these individually. If we compare the skulls of a Homo sapien, which is a human on the very right-hand side, to that of an African ape on the very left, we notice that the brain of humans are bigger in comparison to its face. So humans don't necessarily have larger brains than some apes. I mean, a gorilla will have a larger brain than a human. But what we mean by large brain is that to scale, the brain space is bigger than the face space in a human. If you then look at the African ape, the brain is smaller than the face. So in an ape, there would be more face space than there is brain space. And that is a sign of intelligence in the case of humans. The skull in the middle is of a human ancestor called Homo habilis. And what's interesting here is that the brain is a little bit bigger than in an ape. However, the jaw is still big. So it's really something between human and an ape. But we'll look at that one a bit later. Another thing that can be learned from the skull is the jaw. So if you look at the upper jaw or the palate, you can see that in humans, the palate is rounded. The dental arch is rounded and there's no diastema. Now, a diastema is a space between the incisors and the canine, which you find in carnivorous animals and in apes. Humans don't have a diastema. They've got really small canines and the palate is rounded. In apes, the palate is more U-shaped or elongated to the front, and you can clearly see there's larger canines and a distinct diastema. Now, all of these characteristics that we find in a human shows that we have a distinct omnivorous diet. When we look at the profile of a complete skull, on the left we can see a human skull and the face is completely flat. There isn't a protruding lower jaw, so we say that it's got reduced prognathism, and there's also a distinct forehead and the cranial and brow ridges are really small, versus the guy on the right hand side, which is a fossil of a human ancestor, and you can clearly see the lower jaw is more protruding outward and there's distinct brow ridges. Now, probably one of the most important bits of evidence that is distinguishing humans from apes is the presence of bipedalism. Now, bipedalism, we already said, is walking upright on 2 feet. Now, the criteria listed here, all 6 of them, is important features of a skeleton. If we look at the skeleton, that'll show that this organism was walking upright. Let's look at them individually. The first one is the position of the foramen magnum. Now, the foramen magnum is a hole or an opening at the base of the skull where the spine will go in. If the foramen magnum is positioned centrally, like in the middle underneath the skull, we know that this organism was walking upright. When the foramen magnum is at the back of the skull, we know that this organism was walking on all fours or quadrupedal. Here we can clearly see where the neck area or the spine goes into the skull. We see in a human, it is in the center, so that's why the foramen magnum will be on the centrally located position under the skull. And then for animals that are on all fours, the neck or the spine will go into the back of the skull. The shape of the spine will also be different whether you walk on all fours or walk upright. If you look at the spine of a chimp or an ape, that is knuckle walking, in other words, down with the front of the body resting on the knuckles or the hands, the shape of the spine is more rounded, while in humans, the spine is S-shaped to actually accommodate and absorb shock as you tread, as you step. The pelvis is also completely different in knuckle walkers or quadrupedal animals versus bipedal animals, or bipedal humans for that matter. The pelvis is shorter and broader in the case of a person walking upright, while in apes, the pelvis will be narrow and longer. You can also see that the femur, as it goes into the hip, it is angled inward. In other words, the body is carried on top of the legs, while with apes, it's different. They're not made to walk upright, so their hips don't have to carry the entire upper body weight. They lean forward with their upper body, and there's very little weight on the pelvis. Apes climb trees, and for this reason, their big toe is completely divergent. In other words, their feet would look like a human hand, with the big toe separate, like to the one side, like a human's hand would be. However, animals or humans that are bipedal will have a non-divergent big toe, which means the big toe is more in line with the other toes. Animals that climb trees and have a big a divergent toe also have flat feet. So apes have flat feet. But humans have what we call a foot arch. So the bottom half or the underneath of the foot is arched. It's not flat. And this is so that it can help absorb shock when you walk in an upright stride. So we've just gone through a huge amount of information. So again, I'm going to show you or teach you a cheat way to remember all this information. Now, if you look at this little green stick figure I made here, very artistic, of course, because you know how skilled I am at my art. This stick figure in green, if you could draw this on the right-hand side of your page when you have a question paper, it should remind you of every bit of information that we went through just now. The text given in red is just for bipedalism, the characteristics for bipedalism, and then the ones in the white are the other characteristics that is distinctive to humans. So if you learn the whole lot of them together, going with the sketch, this is how it goes. The wiggly backbone should remind you of the S-shaped spine. The dot at the top of the spine is for the centrally placed foramen magnum. Then we've got the hips, which is pretty rectangular, but that should remind you of the short, wide, broad pelvis with the inward angle attached to that, and then the curved foot with a non-opposable big toe. The face or the head shows you all the features of the skull, a large brain, distinct forehead, reduced brow ridges, and then a rounded jaw and dental arch with small canines. So in an exam, if you can draw this stunning green little stick man of mine, it should be a cheat way of remembering all the criteria that makes humans distinct from apes. Then besides the fossil evidence, there's a huge amount of archaeological evidence. So the fact that humans make tools or use tools, have art, can make fire, have burial rituals, various hunting techniques, all make us different and more intelligent than apes. Genetic evidence is also used to compare living hominids with one another. Now remember, fossil DNA is very rare. So we've already looked at this when we did genetics, but we're going to come back to this a bit later as well, where chromosomal DNA show similarities, will show relatedness, and then especially mitochondrial DNA can be used to show the path of evolution.